بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Today we're going to have a lecture about IoT security. So in the previous lecture we have introduced the different IoT ecosystem from functional perspective, starting from the sensors, the actuators, and we talk about the connectivity between the sensors with RabbitMQ, MQTT, and different type of protocols. But this world is not perfect. There are always malicious people that try to make some harms, that try to steal your data, and we need to care about these issues. And this is more about the non-functional aspects in the IoT, which includes security aspects, quality of service aspects, and security is pretty much important, as we're going to see today. So the outline of the lecture, I'm going to provide an introduction and a motivating example. So remember, in the previous lecture, we've made an IoT agriculture application where we generate data from sensors, we send to RabbitMQ, and we visualize on the dashboard. So it was working fine, but today I'm going to show you, if you put this in practice, you can get your data stolen. You can get people manipulating your data even without you know. So I'm going to demonstrate this. If we don't implement security aspects, what could happen? And this will give you some sense about the importance of integrating security into the applications. And this is why cybersecurity, in addition to artificial intelligence, are like the two most probably important topics currently. And cybersecurity, because everybody cares about their assets. And IoT are part of the assets that the company could have or some people could have. And we talk about the pillars of security, which includes confidentiality, integrity, availability. I'm going also to elaborate on some of the IoT threats, like eavesdropping, man in the middle, and what are the mitigation strategies. And we will finish by doing hands-on activities about how we can implement security mitigation techniques to prevent the different type of attacks. So at the end of the lecture, you will be able to analyze security requirements for IoT applications and identify threats related to confidentiality, to integrity, and to availability within the context of the IoT. We'll be able to identify the common threats and also to apply appropriate mitigation techniques to reduce the impact of these threats. So I'm going to come back to the agriculture IoT application that we introduced in the previous lecture to show you how we can communicate between different consumers and different publishers through the RabbitMQ, which act as a middleware with different type of exchanges. And we have run the application. So you can find on the same GitHub repository an IoT security folder, which will introduce the security threats. So there are different codes about security threats, which I'm going to demonstrate now, and also the mitigation techniques to avoid these different type of attacks. I'm going to start with the demo, but this is now what you can see in the GitHub. So I put some security threats or attacks related to eavesdropping, man in the middle, spoofing, and stealing the data, and also the countermeasures in order to prevent these type of security attacks. So I'm going to start by a demo. And here, if you remember, last time we ran the IoT application by running a sensor emitter and also a web data server. And we were able to see that the data that is submitted by the emitter goes to RabbitMQ and then dispatched correctly to the front end in the HTML. And today we're going to introduce different type of attacks, and you will see the impact of the non-secure IoT architecture when there are attackers, like for example, some malicious nodes could introduce message spoofing or man-in-the-middle attack, and we will see this now in practice. So let me just go here, and I'm going to start by the demonstration from the last lecture, just to make a refresher. This is our sensor emitter. It's not secure. It just sends the data in plain, without any security, without. Okay, I need to change this Wi-Fi. Okay. So this is our IoT sensors. They are sending data about temperature, humidity, soil moisture, and we should be able to see the values in this front end. But now we don't see anything because I didn't start the server, the web data server. I'm going to start it, and this web data server is also not secure. So doing that, our application from functional perspective, it works. And this should be fine if this world doesn't have malicious people that could make some harm. And I have here an application also that will make security monitoring. So it will check whether there are kind of abnormal behavior that we can detect. And now I'm going to start an attacker. So I have two types of attackers here. The first one is just an attacker, okay, or the simplest one, probably also the most dangerous because sometimes it's difficult to find it. It's an attacker that will sniff the network. Look now, this is going to run in the background. Just we wait a little bit. So this is an independent node. We don't know about it. We don't know that it even exists. And look now. Look at our data. This is our data here, 37. It was collected without even knowing. So imagine that this data was a camera, surveillance camera that is inside your home. And there is some other party that is just sniffing this camera. It's a security breach, privacy violation. Okay? So imagine that this farm has competitors and they will just take their data and try to make insights. You know, stealing the data, it's a big issue. And here, because our data is exposed, we didn't do any security aspect. So this node, and you know, we don't even know. So this application, the first application, doesn't even know about this node that is sniffing the data. And this happens also to all public Wi-Fis. You know, sometimes you connect to a public Wi-Fi. You know, many of these are actually not secured. So you should not, for example, log into your bank or providing any kind of credentials because some other party could be just sniffing the network and getting out your data. So what kind of security breach here it was violated?
Eavesdropping.
It's an eavesdropping, yes. But now, what is the confidentiality? So here we lose confidentiality of the data and privacy is now breached. Okay? So this is one type of attack. Okay? Now let's look, and you know, this attack is dangerous because look, it didn't impact our data. Look, all our application is working fine. There is no issue. It's like there is no issue at all. But there are some other attacks that also could make different type of harms, like spoofing. And spoofing, there is someone malicious that is going to inject, okay, wrong data into the network, and this can have different type of implications. So first of all, look, now it's injecting 41, and it's reflected in the dashboard. So if you're looking, monitoring your data, you're finding a temperature suddenly going to 41, 47, and then going back to 20, you know, this disturbing. Okay, a high temperature, for example, can trigger an alarm as a fire or, you know, you don't know, depends. So it can trigger false alarms. Another thing, a spoofer can keep sending information. So, and because most of the IoT devices are battery powered, so it can exhaust the batteries in just quite fast and put them out of service. And this will lead to kind of denial of service attacks, either on the server themselves by flooding them with a lot of messages, or on the devices, so they will deplete their batteries and put them out of the service. So this is also dangerous. Another one is the man in the middle. It means, okay, someone in the middle is going to sniff and change the message, modify the message. And there are, you know, they can modify the message and they can replay the message. And these two are both also critical. We're going to discuss in the lecture about these aspects, but just I want to introduce this from practical perspective. Look now from the man in the middle. Okay, attacker. And this is going to make a big trouble because it's going to receive every message, try to change it immediately. Look now, even the message that it is injected, it is trying to modify immediately, and the whole network is actually compromised. Look at the security detector monitoring, it's kind of in full alert. Okay. Now, this gives you some sense about all the issues that you may have if your application is running, but it's not secure. Now, let's look if we implement a full security solution. So I'm going to run the same application with a secure sensor emitter. What does it mean, a secure sensor emission? So every sensor node needs to be authenticated, okay, before being allowed to submit data. And it must also encrypt its message to ensure confidentiality. And it also makes sure that this message reaches the destination without being altered. So there are a lot of requirements here to ensure a secure emission. Now, on the other hand, I'm going also to launch the same web browser data in a secure manner. Okay, and we will see here, look, what do you observe? Okay, received authenticated data. Now the data is being authenticated. Okay, so look, now it recognizes that the data coming from here is authenticated. And now going back to our front end, so we will have the data coming fine. Now let's replay the same attacks. Let me start by the message spoofer. And let's observe what are the applications. Look, it's sending 45, 47. Is there any impact? No. Nothing. And you can see now, just by implementing security measures, we solved our issues. Okay, now if I replay the man in the middle, and okay, let me just replay the man in the middle. And look, now the authentication is verified and encrypted, the message integrity. Now this is trying to make some trouble to our application, but from end user perspective, you are protected. And because here we have a web server that is secure, that it is able to filter any kind of attack. Okay, it's able to filter any kind of attack, and in this case, we will be able to secure the delivery correctly of the messages. Okay? Okay. So you can see the importance of implementing security aspects. And because usually people, they focus more on implementing the functional requirement of their application, and sometimes they forget about security aspects. And this happened to us, to one of my engineers. We developed an application and we deployed into the server. The same day, a hacker was able to access the database, collected the whole database, sent us an email. If you want to get your data back, you need to pay us money. And alhamdulillah, this data just was a fake data. But imagine that it was for a customer data or production level, that's going to be a big issue. So this is why understanding cybersecurity is really important, because at the time that you deploy anything on the internet, believe me that there are attackers that will try to get something out of this and try to sue you just afterwards. There are just people, this is their job. They only try to find issues. Okay. Yes?
Is there an efficient way to avoid this?
Implementing security, and this is why I'm going to introduce that today.
Is it efficient?
Yeah, for sure. Otherwise, all the different systems should be hacked. And with this, attackers still can find some ways,
Exactly.
There are trivial ways, at least everything that is trivial for hackers, you need to close it. And I'm going to show you some examples. Back in 2016, the hackers were able to hack 600,000 IoT devices over the internet just because they didn't change the default password of the factory. As simple as this. because many of these devices that come with the default password, and people just put it into action and they don't do the effort to change this manually. Okay, they forget or probably they just ignore this process. Okay, we're gonna come back later on to show you in details the code and how it works, but now let's understand the theory behind security and the different aspects. Okay, so this is the demo if you want to run it in secure mode and also in non-secure mode. And I made something also different, very easy. If you want to run it without opening many terminals, you can just make, I can run demo. Look, run demo here is going to provide you a menu, and you can choose run unsecured IoT system. So it will run all the nodes all together. Or you want to run the IoT system, and then you want, this is a TLS, we're going to talk about TLS, run a simulation attack, run security monitor. You can, let me run the first one, and I will run, so now it's playing, and okay, it's now playing. I can run a security attack now. Now it's playing the man in the middle, the spoofing, and the sniffer all together. And you will see, look, now we're going to have the issues that we faced before. If you want to close everything, just press 10, and it's done. It's going to kill all the processes. Did you get a course on cybersecurity or not yet? Yes, okay. So this is going to review all the different aspects that you have learned, but apply to the IoT. And the issue with IoT are the challenges that we talked about here. Yeah, they are resource constrained. We talk about devices that are battery powered. Okay, so this is one of the limitations. And many of these devices, they come with weak authentication mechanism. They have a password like admin or admin123, stuff like this, And they are deployed in large scales, It's not like you have one or two devices that you need to monitor. You talk about millions of devices that you need to monitor over the internet. And the objective of security is to protect these devices from attacks, protect the network, and protect the data. So there are different layers of protections that we need to ensure for our IoT system from the cyber threats. And you need also to safeguard sensitive information during the transmission and ensure the trust in IoT systems and their operation. And security is based on 3 pillars. Of course, you should know this from the cybersecurity course: confidentiality, integrity, and availability. And this is what we call the CIA Triad, or the CIA pillars in the IoT. The confidentiality, it means you must prevent unauthorized access to your data. So your data must be private. And let me know there is no private data over the internet. All your data is exposed to your service providers. That's unfortunate. But, at least you don't expose it to non-service providers. And you need to ensure that the information is only available to intended users and implemented through encryption and access control. Integrity is important. You need to make sure that the data that you send is the data that is received. Okay? So, for example, you don't want to buy an Apple, an iPhone, and then you receive, I don't know, a toy. Okay? A man in the middle can just take the iPhone and just put a toy. And that happened to someone I know, He wanted to buy an iPhone and just received the toy because someone just made the work. So this is what we call integrity of the message. Okay, you need to make sure that your message is unaltered. And the availability, it means that the service is always on, or most of the time. Now we talk about 99.99% of service availability. There is no service provider that's going to tell you 100%, because if it's going to tell you 100% and then drops down, you can sue him and put him into legal issues. So we need to guarantee the reliability of and access of the IoT devices and prevent denial of service attacks, either on servers or on the IoT devices. So again, these are the most important pillars that we need to satisfy. Confidentiality, it means protecting sensitive data. And for this, we need to use encryption techniques. For sensor data transmission, we provide secure device authentication to make sure that we authenticate every node before being able to submit, the access control, the data anonymization for privacy issues, and secure key management. For the integrity, we need to make sure that the data and the comments are not changed while transmitted over the internet, and they are maintaining their accuracy and their consistency. And the availability, as already mentioned, the system must be always accessible and resilient to denial of service attacks. Do you know what is DDoS? Denial of service. Okay, so, and the hackers, what they do, if the server is not scalable enough, they will keep sending a lot of messages until it will not be able to respond to other legitimate end users. And for this, you can use firewalls or other kind of techniques to prevent these type of attacks on your own server, or doing load balancing. When you have a lot of messages coming, you can send them on different servers. And now with technology of cloud services, so they can scale up and down the number of servers to be deployed based on the number of requests that is received. Okay, let's start with confidentiality. It ensures that the sensitive data remains private and accessible only to authorized users. You don't want, for example, your security camera can be disclosed to others because it's gonna record your private life, and nobody would like to have this. So we need to ensure an end-to-end security and encryption between the servers and the camera, or the end users and the camera, to prevent unauthorized access to this private information. And we want to protect the user privacy. So confidentiality has to do with user privacy because and non-disclosure of the sensitive data. So why this matters? Because confidentiality breaches in IoT can lead to theft of identity, fraud, financial fraud, for example, stolen money. Okay, somebody can actually steal your money, or physical security risks. Now, for example, if your data is not private, some maybe criminals can understand that you're not within your house by making inference about, I don't know, motion data, motion sensors or everything, and they can just make sure that you are not there, and they can steal your house during that period, okay, if certain information is exposed. And in our agriculture scenario, the unauthorized access to farm data could reveal proprietary farming methods and give competitors an unfair advantage if they know what are your practices, what is the data that is being used. And there are different ways on how we can implement confidentiality. We can use TLS encryption, which is transport layer security, and this encrypts the data in transit and can be used to encrypt MQTT, HTTPS connections. And there is also a counterpart for datagrams. Okay, datagrams لأنه غالبا they are lighter weight, and TLS is heavy. For small devices like IoT devices, Arduino nodes, they might not be able to support the computation overhead of TLS, so there is another counterpart which is lighter weight that allows to secure IoT devices with limited resources. This is a big challenge. Look now, if I want to secure this Mac laptop, it's much easier than securing a small Arduino device. Okay, because computation-wise, you know, the Atmega 16, it has only very limited computing and memory capabilities. So if you're gonna store an encryption key of 256, you may overload the whole memory of an Arduino Uno, for example. So it's challenging because you have resource limitations. And there are other techniques like, for example, key management. Okay, how to secure a key. Some people put the key hard-coded inside the device. You know, if someone would have access to this device, plug a USB and then can steal this encryption. So there are other techniques like, for example, public-private security keys, and there are some trust centers that will deliver you a certificate that you can install locally to be able to communicate. You know, there are different ways on how this can be achieved. And you must also encrypt every kind of data stored on your devices. So for example, if you have a database, you must encrypt all your data in your database, because if this database was accessible to others, they could access the database, but they should not be able to access the data. The data should be securely encrypted. And typical use of AES 256 encryption for any sensitive data stored locally on IoT devices or in the cloud to prevent data exposure or physical access if compromised. So even if you use an encryption key inside the device, you must make sure that this key also must be also encrypted with a key that others don't know. Okay, so this also some examples about the secure communication. In IoT, we talked about TLS and DTLS. HTTPS also is another alternative used in IoT, especially for the communication between a node and the cloud. Okay, and this is used for firmware update. Firmware, this is like the code that you upload on Arduino. This is what we call firmware. And imagine that this firmware is exposed. Anyone could inject a firmware and let your node behave in a different way. For example, instead of sending to only the legitimate server, it can send to other servers and keeps that sniffing over you without knowing about this. So firmware security is also very important, and this can be prevented by signing the firmware. Okay, so the firmware should be signed, should be authenticated by authorized users, so not everyone can actually update the physical hardware with a firmware that is not signed. وتشوفوه انتم بعض الأحيان حتى في تطبيقات الجوال, if you find an APK you would like to install it, it can tell you that this APK is not signed, so there is a security issue. We don't know about who is the author of this APK, which is actually the mobile application, okay, installer. So same thing also for embedded devices. We need to make sure that their firmware is also protected. Now we're done with about confidentiality. The second pillar is data integrity. And here we must ensure that the data is not changed. Okay, and to prevent unauthorized data alteration, not even access, but also alteration. And this, the data integrity is possible when people are able to access this data. So what are the measures to prevent changing the data without being undetected? Authentication. Okay, now, authentication, it tells about confidentiality. So, identifying the node that is going to send or receive. Like now about data integrity, I want to detect that the data has changed. So we can use techniques like hashes. What is a hash?
Hash is adding symbols like encryption.
Hmm?
Something like encryption. Adding hashes.
Yeah, you can think about a hash. It's like a digest representation of the data, such that if anything changes in the data, the hash is going to be completely different. So for example, you send a packet with certain values, and then at the end you will append a hash. And there is a man in the middle that take this value and change any of these values. So later on when you receive it, you're going to calculate the hash of the received packet. And you will compare it with the hash that was sent. It cannot change this hash again. And in this case, if there is a difference in hashes, you know that your data was changed. So hash is one of the techniques that is used. Okay, cryptographic hashes create fingerprint, بصمة على البيانات. أي شيء يتغير في البيانات البصمة الكل تتغير. Okay, if you received a packet with a different hash value, in this case, you know that your data was changed. So you know that there is a security attack on your data. So you don't trust it, and you have to make proper actions related to this. The second way is the digital signature, التوقيع الإلكتروني. So, which is basically a hash plus encryption. We don't only make a hashing, but we will encrypt the data as well. So the encryption is like a signature, توقيع. Okay, so critical commands are signed with private keys. And receiver, this is the hash mark. It combines both the encryption and the hashes. But here the digital signature is basically you sign with a private key. In asymmetric key cases, you have a public key and a private key. Private key, this is your own. Nobody knows about it. And the private and the public key, it's public. Everybody knows it. So for example, if the sender send you a message encrypted with the private key, you can decrypt it with the public key. And if you send with the public key, you can only decrypt it with your private key. So this is a way to ensure the integrity of the message. The receiver verify with public keys to confirm both integrity and also the sender authentication, both together. So the secure boot, also the firmware that you need to upload on an embedded device has to be signed. Okay, has to be signed with a private key. Okay, preventing unauthorized code execution even if the device is compromised. مثلا الآن تريد تحديث الفيرموير من البروفايدر. Provider has what? Has a private key. So it's going to send you a code that is encrypted with his private key. How do you know that this code comes from the provider? How do you know that this code comes from the provider? With the public key. Of course, public key بيوزعها لكل العملاء. So when you receive this encrypted code, you're going to apply the public key. If the code was deciphered correctly, you know that that was signed by the owner. If you find any discrepancy, you know that this code is not signed by the owner, so you have to be skeptical about using it. So this is the way how we can use private keys in order to authenticate the users, preventing unauthorized code execution even if the device is compromised. And okay. Now you have to make a difference between hash and hashmark. Did you see this in cybersecurity? The difference between hash and hashmark? Okay, let's start by the hash function. As already, hash function takes an input data and produces a fixed size string of bytes, which is called the digest. وإلا the hash. It's like a fingerprint representation of your data that is unique to the input. مستحيل أي input آخر مستحيل. It's impossible that is going to lead the same hash. فالhash function they are built in a way that they are unique to any kind of data. لو تغير capital to lower case يعطيك completely different hash. Okay, so the purpose is to ensure data integrity, verifying the data hasn't changed. And the key feature is one way, no secret. مثلا you don't have any function that from the hash you can recover. صعب جدا. It's almost impossible. لكن still, if you have a weak hash function, theoretically it's possible, but practically it's very difficult. This is why, and this is how we can implement it. Look, you take a data, you apply a hash function from hashlib import hashlib in Python, and you apply ssh256.encode and digest. So this is going to provide you the following hash, and this is the fingerprint of hello. If you change anything in the string, you put hello with lowercase, you're going to have a completely different hash. So the hashmark, it combines both a hash function plus cryptography using secret key to also encrypt, to produce a message authentication code. So this hash function is going to be also encrypted, and this will ensure both the data integrity and also the authentication. So this private key is going to be used to encrypt the hash value, and this will ensure both the integrity and the authentication, and this will require a secret key to decrypt, and then we will apply the hash function on the received message to compare the two hashes all together. And this is the difference. Now we can use hashmark.new. We provide the key that you will use to encryption. So this is symmetric key. It's secret. Must be stored locally. Okay? And you apply the hashlib, okay, the same that we applied here on the data dot hexa digest. So what is the difference between hash and hashmark? Just in one sentence. Hashmark adds encryption to the hash function. واضح? And this will allow both, look, integrity and authentication. وهذه فقط تعطينا data integrity. يعني if you have a hash function, you are sure that your data was not changed, but you don't know who has sent this data. When you have a hashmark, you are both sure that your data wasn't changed, and you are sure about that it was sent by an authorized user. هذا هو الفرق. This is like a more sophisticated functionality than the hash. واضح? Integrity and authentication, and this one is only data integrity. To summarize, okay, so the hash doesn't use any key. The hash mark will require a secret key, a symmetric key to encrypt. So this one, it will ensure the integrity. This one, it will ensure the integrity and the authentication. This, from security perspective, this could be vulnerable to tampering, to changing the data, if the hash function is weak. But usually, if you use a hash function with 256, it's almost impossible. But this is more resistant to tampering because you add an encryption also, so you make it more difficult for the hacker to extract the data. Okay, so let's talk about digital signature, التوقيع الإلكتروني, for critical command and firmware updates. So a digital signature ensures that the data, like command or firmware update, is authentic and not changed. It provides integrity, that data is not changed, and also authentication. It comes from the expected user. So here, from the sender perspective, the sender is going to create a hash, and here it will encrypt with a private key. بشو الفرق الآن؟ شوف، لأنه هذه الآن تعطيني integrity and authenticity الاثنين, and this one will give me the same. But what is the difference? It's the type of encryption. Here we use symmetric key encryption. It's a secret key that is shared. هي نفسها. Okay, I will give you a key, I will take the key, and we will share this key all together. There is no private public. It's not asymmetric. If you want to make it a digital signature, خلاص ما لها توقيع خاص بي. فالكي أصبحت الآن private. ما عادش كي عام. If the key is public, it's not yours. So it's not my signature. لكن my signature, it means that this key is mine. And this is here, the hash is encrypted with a private key. So it can be only decoded with the public key of that particular sender. So in this case, I can authenticate that sender. يعني الآن مش نستعمل public key that is related to that particular sender. It's not a public key that everyone knows. Okay, but the public key will only help to decode this private key, creating a digital signature. And it will send both the data and the signature of the receiver. At the receiver side, أنا جتني البيانات، نحن نتأكد هل البيانات هذه تغيرت and does it come from the intended sender. So what I will do, first of all, we will apply the public key, and if it works, I know that it comes from the authentic sender. If it doesn't work, so there is an issue. And then I will take the hash and we'll compare. I will apply the same hash function on the data received and compare the two hashes. If the two hashes differs, it means the data was changed, so I'm not going to trust it. If the two hashes are the same, so I'm going to say that the data comes from the intended sender and is authentic, is correct. واضح ولا يا شباب؟ Okay. And this is how it works in practice. هذا السندر، شوف السندر عنده بيانات، يعمل هاش، ياخذ البرايفت كي ويعمل digital signature، ثم will send the data and the signature. عبارة عندي رسالة وعملت عليها ختم، وقعتها. اوكي. الآن إذا وصلت للريسيفر it will take the data. جاتني الرسالة الآن، حاب نعرف الختم هذا صحيح أو خطأ. فأول شيء I'm going to use the public key، نتأكد من الختم صحيح. Fine. I go to the next stage. الرسالة هذه تغيرت ولا ما تغيرتش؟ يمكن شخص في الوسط مش عمل الختم، حصل على ختم صحيح وغير الرسالة. اوكي. أو شخص دخل المكتب استغل الفرصة وكتب رسالة أخرى وأخذها نفس الختم وأرسل. إذا الوقت نشوف الهاش فانكشن. الهاش فانكشن مستحيل يتغير. Okay, so in this case we compare the hash, and if the hash is the same, in this case I will accept the message as being delivered. Yes. signature. signature هو البرايفت كي، يتعلق بالبرايفت كي.
What is it made up of?
It's based on the concept of asymmetric key cryptography. Okay, you should have seen this in cybersecurity course. اللي هو الآن you encrypt with the private key and you decrypt with the public key. So the key that you use in encryption and the key that you use in decryption are different. In the case of symmetric key cryptography, the same key that is used in encryption, it's used for decryption. طبعا for symmetric key cryptography you cannot know who is the sender لأنه the secret key can be shared among multiple users. In the context of asymmetric key cryptography, you have a private key that's your own key خاصة بي ما يعرفها ولا شخص. Okay? In this case إلا إذا كان شخص تحصل عليها بطريقة معينة. Well, otherwise if you encrypt, this is why it's called, this is اسمها signature. توقيعي أنا مختلف على توقيعك. لما نرسل ورقة الآن لما تمشي للبنك عندك شيك شوفوا التوقيع، إذا التوقيع غير مطابق المكتوب عنده ما يصرفش، يعني يعرف هذا توقيع خاص بي أنا ما يشاركني في شخص. Okay, so this is the same thing, it's a digital signature، هو توقيع إلكتروني يضمن. طبعا الآن أصبح فيه البلوك تشين والسوفيستيكيتد تكنيكس هذوما to ensure immutability integrity authentication and these different type of things. Okay, واضح. Okay, for secure firmware updates نفس الشيء, we use the signature to sign الcode. الآن I will sign the code to make sure that at startup the device checks the firmware digital signature using the manufacturer public key. So I want allow من الآن تشوفوا هذا الجوال ايفون ولا سامسونج from time to time it would like to make an update. صح ولا لا؟ You made several updates. So this is a firmware update. Imagine that this phone doesn't take signed firmware updates. ممكن يجي شخص آخر يعمل لك شيء مثل بلاي ستور وياخدك يقول لك there is a new update. You click here, it's an iOS, لكن the guy is making some malware, stealing your photos, stealing your messages, accessing your phone without even you know. Now this is impossible. لأنه أبل يشترطوا طبعا أبل they have very strong security protocols. You cannot install anything on iOS only if it is signed by Apple. Okay, using a digital signature. So now if you have an IoT device and you have a temperate firmware, there is a malicious guy who would like to send a firmware to update your device, an IoT or a mobile phone or whatever. So the signature verification is going to block this from being installed. لذلك الآن حتى بعض الأحيان when you install something on Apple ولا على Windows يقول لك this software is not signed ويعمل لك security إلا ما تروح للسecurity اللي في الأبل and say okay install this software, so it will be at your own risk. But usually this operating system they have mechanisms to check whether the software is authenticated by authorized users. Okay, حتى الآن if you make an Apple developer account you will have a personal signature related to your account. So Apple will allow you later on to post it on Apple Store and being downloaded by others. Okay, so here based on the signature verification, if the signature is valid the boot device normally, and you can also update the firmware, or otherwise it will refuse to update that firmware. The third security threat is about availability. وهذا أيضا مهم جدا. تخيل الآن you would like to download an application from iOS and you cannot. It's out of service. Okay. هذا بعض الأحيان تمشي الخدمة يقول لك السيستم عطلان. This is a denial of service, and it can be made by an attack. Okay, usually they will jam the server with a lot of messages at the same time and try to make it out of service. So what does it mean? It ensures that the system remain operational and accessible when needed. And this is critical for devices performing time-sensitive and mission-critical tasks. تخيل عندك مثلا شيء عاجل صار fire and you want to deliver this fire by an alert and the system is not responding. It can lead to a disaster. So availability is something really important, and cloud servers usually they tell you we can provide you reliability up to 99 dot, I don't know, much percentage of service being uptime. And even they must inform the users in advance when their service is going to be down. So they can make special measures, okay, and inform their customers or reschedule their time-sensitive and mission-critical tasks. There are different ways on how to implement availability, like for example, input validation. شو هم attackers الآن? You put any servers, for example, an endpoint, and they can sometimes inject a code within the request, within the query input. Okay, if you don't do proper data validation, I'm not sure إذا عملت مثلا web programming with server-side scripting, there are techniques and they can inject some command into PHP or into the back-end server, and this will be converted into a code that will be locally executed and can make a lot of disasters. So input validation, it means you're going to prevent any kind of suspicious characters or inputs to filter it out to prevent any kind of attacks. And so the attackers can make buffer overflows, can make injections of attacks, and can lead to crash the device software, keeping the devices operational. Another possible attack is on the network itself, okay, by sending a lot of messages at the same time. ولذلك الآن any kind of online service يعطيك فقط how many messages you can send in a certain amount of time. مثلا يقول لك تستطيع ترسل 1000 message في الدقيقة. You cannot send more. لأنه this is the capacity of their service. And to prevent networking attacks, we can implement firewalls by limiting the rate that mitigate the effect of denial of service attacks, and also make network segmentation. لما يجيني مثلا one request, I will not send it to the same server. I will send it to one server, second server, three server. Sometimes you make a replication of 10 servers. If you have, like for example, imagine Google or iOS, they have millions of users. They're not going to be all served from a local server. So you have replica. Some of the replica, for example, in the US, in Europe, in the Gulf. So wherever your location, you're going to be dispatched to particular type of servers. And redundancy. This is the application. I can also have the same data replicated in different locations. So for example, if the server is down, I'm going to reroute it to another one. And the power management, so prevent battery drain attacks by implementing sleep modes. لأنه الآن if you have an IoT device and the attacker gain access to it, you know, it can just keep sending messages, whatever message it is. Imagine that he is going always to respond. Imagine that someone is just, you know, you saying anything and keep you listening until it drains all your energy. So same thing, we can keep this IoT device just listening until deplete all the energy and then goes out of the service, and it cannot report any kind of data. So these are the issues related to availability, and the threat prevented is denial of service attacks, signal jamming, radio for example. If you work on wireless, I can make jamming, for example GPS spoofing or jamming or device crashing, or also battery depletion. And this is amazing. Look, this happens back in 2016. The Mirai botnet compromised over 600,000 IoT devices, including cameras and routers, by exploiting default credentials. They didn't change default credentials, and they were just exploring whatever device is accessible on the internet. They will try to access it using default credentials. And there are, I think, 65 combinations of known credentials. They've been trying all these different type of combinations. And finally, they gained access. They targeted DNS provider like Twitter, Netflix, Reddit, and they demonstrated how it could have a massive internet outages and disastrous effects. Look now how many, it's more than 600K infected devices, 1 terabit per second of peak attack traffic, and plus 60 default credential targeted. They've tried different type of non-credentials on IoT devices. They were attacking routers, IP cameras, internet televisions, okay, by trying to access them through default credentials. So when you buy any smart device at your home, Alexa or whatever, try to make proper credentials so you don't expose them to attackers. So practical availability measures. We talked about this: device hardening, network protections, and different things. Okay, I'm going to stop here, and next time I'm going to talk about the IoT threats, the most important IoT threats. Today I made a demo about these IoT threats, which include eavesdropping, okay, which is dangerous because this is a passive attack. It's not active because it's not going to change your data, so you don't know about it. It's passive attack where attackers intercept and monitor unencrypted data. For example, if you connect to a public Wi-Fi network and you make a transaction through your mobile phone, maybe some people could they could leak your Visa card credentials and gain access to it. So transmitted between IoT devices and servers. And the potential impact is confidential data exposure, privacy violations, and credential theft. In order to mitigate the issue, we can use a strong encryption using TLS for all data transmissions. This is for eavesdropping. Man in the middle is someone that is going to be in the middle. So eavesdropping can be done by a man in the middle, but the man in the middle can do something different. It can inject false data, can take the data and then send a different type of data, and this is called data manipulation. It can send false command execution. For example, we can make your water pump working all the time. Okay, it's going to exhaust all your water resources without even and unauthorized access to resources. To mitigate the risk of man in the middle, you can add digital signature. عملنا توقيع، فما أي شخص يستطيع يرسل الآن لأنه يحتاج توقيع إلكتروني. So digital signature is the first measure that we can take. We can also use message authentication code, the MAC or the HMAC, اللي هو عبارة على hash function, okay, with encryption and certificate validation. We will talk about this in the future, in the next lecture. The third attack is the weak authentication, اللي هي كانت المشكلة اللي تسبب فيها ميراي botnet. Exploitation of default passwords and shared keys to gain unauthorized access to IoT devices. And the potential impact is the device hijacking, اختطاف. Hijacking يعني اختطاف. Okay, so you took control over a device and you let this device do whatever you want. And the botnet recruitment and also data breaches. So to mitigate against this, you need to change your password to be unique, to be strong. You can use multi-factor authentication. Now this is very popular. مثل حتى الإيميلات الآن مثلا في الجامعة, you need to use multi-factor authentication and secure key management. The last attack we will talk about is the replay attack. هي من نفس المان in the middle, لكن عوضا أنه it change the data, no, it will delay the data for some time and replay it later. حتى لو تعمل لها هاش, نفس الداتا مش ياخذها هي نفسها, مش يرسلها. مثلا أنت الآن عندك باب إلكتروني يفتح بالبصمة, فتح, طبعا أرسل هو مسج encrypted وفي هاش كود وكل شيء, أخذته هو نفسه, ثم تركته ساعة, راح الشخص, الباب مغلق الآن. I will replay it. يمكن يفتح باب سيارة, يمكن يفتح باب منزل, just by replaying the same. فهاو to mitigate against this, نعمل sequence number مثلا, نعمل time stamp. فالمسج مثلا إذا كان تم تشغيله بسيكونس نمبر رقم 10, إذا رجع من جديد برقم 10 I will not replay it. إذا يغير الرقم 10 الهاش فانكشن ما عادش يشتغل, خاطر غير معلومة. فممكن نستعمله ما يسمى بالنونس ولا سيكونس نمبر ولا تايم ستامبس. فشفتوا الآن يعني replay attacks is very difficult because it's gonna replay the same thing. ياخذ هو نفسه encrypted message يعاود يرسله زي ما هو, مش يفتح بيه باب سيارة أو باب منزل or anything else. Okay, so that's all for today. So next lecture we're going to talk about these different type of attacks and what are the security measures to prevent them. Any question?